Okay, so let's start a new chapter. We're dealing with radical exponents, radicals, and complex numbers. The very first section we're dealing with involves radical expressions and their functions. So here are our objectives. First, we're going to find the square root. We're going to use a calculator to find the square root. We're going to find cube roots, and we're going to find other roots. So, something I'd like you to notice. The notation for square root is actually this notation. The 2 means square. This symbol means root. But we've used square roots so often that they will just write the symbol alone without the number on the upper left corner. By the way, that number is known as the index. And technically there should be a 2 there if they're talking about a square root. But again, over time it's been dropped because we use square roots so often that they drop it. But when you're looking for a cubed root, you use that symbol for root, and then you need to put the index. I need to put a 3 there so I know I'm dealing with a cubed root. If I don't put it there, then I'm dealing with a square root, so be very aware of that. We're going to be looking at other roots. 4th roots, 5th roots, nth roots. Okay, so understand the notations, please. So, the opposite of squaring a number is taking the square root of a number. So, for instance, we're used to saying 5 to the 2nd power. And what is that? Yes, it's 25. But in this particular case, we're going to be taking the square root of 25. And I know you know the answer. It's what? Yeah, it's 5. But understand something. The reason it's 5 is this. Because you're looking for 2 of a kind. Square root means I need 2 of a kind. I know 25 is 5 times 5. Another way to write 5 times 5, 5 to the 2nd power. I'm looking for 2 of a kind. Since I have 2 5s under a square root, I have 2 5s under the square root. That means the square root would just be simply a 5. Yes. Are y'all with me? Okay, so let's take a look. I'm trying to find the square root of each of these numbers. Now remember, if I'm looking for the square root of 36, I'm looking for 2 of a kind. I'm looking for 2 numbers that will multiply to 36. I bet you already have the answer, don't you? And I bet you said the number was 6, didn't you? Cool. Let's take a closer look. I know 6 times 6 is going to be 36. 2 positive 6s multiplied together is 36. But 2 negative 6s multiplied together will also give me a 36, which means the square root of 36 is not just a positive 6, it's also a negative 6. With me? Okay, take a look at the next one. So, you know the square root of 81. You know it's 9, but it's not just a positive 9, it's a negative 9 also. 2 negative 9s multiplied together also give me an 81, which is why the answer in this case is 9 and a negative 9. Now, let's take a look at this last one. I am looking for the square root of negative 16. Remember, they usually don't write the little index of 2 there. So I'm looking for 2 of a kind. So the question is, what 2 numbers will multiply to 16? Well, if you said 4 and negative 4, that's true. But square means I need 2 of a kind. I need 2 of the exact same number. 4 and negative 4 are not the exact same number. And if you're like, well, what about 2 positive 4s? Well, that's great, but that doesn't give me a negative 16. Well, what about 2 negative 4s? That's great, but it still doesn't give me a negative 16. So my question is this. Do I have 2 of a kind? Do I have 2 of the exact same number that will multiply to a negative 16? Correct, the answer is no. So, there is no real number whose square is negative 16.
The number negative 16 has no square root to it, no real square root. None of our numbers we're used to will give me a negative 16 when I try to take two of a kind. Does that make sense? Lovely. Now, notice what it says here. The principal square root of a non-negative number, right? Non-negative. We just saw in the last example, you can't take the square root of a negative 16, is a non-negative answer. Whereas a negative square root of a number is negative. So let me kind of simplify that a little bit. Do you notice in front of this particular square root sign, is there anything written? No. So it's automatically assumed to be a positive, correct? Do you notice in front of here, there's a negative, isn't there? So let me go back to our lovely 25, the square root of 25. Now I know you know the answer is 5. That's true. I'm going to write this out twice for a moment. Humor me. Just watch along. Okay? Now, here's where you're humoring me. If there was a positive in front of that square root of 25, your answer would be what kind of 5? Correct. It would also be a positive 25. Or pardon me, a positive 5. So, the square root of 25 with a positive sign in front of it will give me a positive 5 answer. Now, what happens if that square root of 25 had a negative in front of it? This 5, this answer, would it still be positive? No, you're right, it wouldn't. It would also be negative. Does that make sense? And let me explain that just a little bit better. Technically, there's a negative 1 in front of the square root of 25. Which means I would technically have a negative 1 times 5, which is how I'm getting this negative 5. Good? Okay. Let's take a look at these particular examples. Notice, do you notice there's no index written here? That automatically means it's a 2, which automatically means that I am looking for the square root of 49. So you know. Okay, and you know what the square root of 49 is as well as I do. What is it? Good. It is 7. Now, question, is your answer going to be a positive 7 or negative 7? Hopefully you said positive because there's a positive sign in front, isn't there? There's your positive 7. Now, what about the square root of 1? Yes. You said it. I know you did. It's a 1. But again, what sign is in front? Yeah, there's a positive sign in front, which means your answer is a positive 1. Now, letter C. Here's the deal. Do you notice between the 25 and the 16 is a division sign? Division is not superglue. Remember that. Division is not superglue. We've talked about that before. The only operations that are superglue operations are addition and subtraction. These are our superglue operations. So in this particular case, when they're looking at the square root of this fraction, I can literally look at it as the square root of 25 over the square root of 16. But you know what the square root of 25 is? Yeah, 5. You also know what the square root of 16 is? Yeah, 4. And since there's a positive sign in front, this answer is a positive. Good? Make sense? Okay. Now, the square root of this wonderful little decimal. Well, you know what the square root of 81 is. What is it? Yeah, that's a 9. And I know you'll head to your calculators, which gives you the 0.9. Good? Okay, now let's look at letter E. I'm going to explain how letter E actually comes about. According to what's under there, I have X. How many times? Yeah, 10 times. So I'm going to have you humor me as I write out 10 X's. Okay? Because most of us are visual people, and so sometimes this makes it a little bit easier to see. Now, what root am I dealing with? Yes, I'm dealing with a square root, which means you're looking for two of a kind, aren't you? I am looking to take these 10 x's and cut them into 2 pieces. And I need the exact same amount in each piece, which means you would have how many x's in each piece? Yes, 2 of them. Pardon me, 5 of them. I have 5 x's on the first piece, and I have the exact same number on the second piece, which means the square root of x to the power of 10 is x to the power of, 5, because I have each piece with 5 x's in it. Cool? Okay, now, letter F. What operation, first and foremost, is between the 36 and the x to the 6? That's right, that's multiplication in between them. Since that's multiplication, I can look at them separately. I can look at it taking the square root of 36 times the square root of x to the power of 6. Okay, you know what the square root of 36 is. What is it? Yes, that's 6. Now, what about those x's? How many x's do we have? That's right, we have 6 of them. So again, for us visual people, I'm going to write them down. And technically, that's a square root, correct? Which means I need to take these x's and I need to cut them into how many pieces? 2 pieces. So, and each piece needs the same number of x's, which means each piece will have x to the third, or 3 x's in them. Does that make sense? Which is why your answer is 6 from the 36, and x to the third from the x to the power of 6 being cut in half. Cool? Okay. But again, positive sign in front, this answer is also positive, isn't it? Okay, look at letter G. What sign's in front? Yeah, negative, which means your answer is going to be what? Yeah, negative. And again, you know the square root of 25. So letter G, this answer should be no surprise to you. Okay, last but not least, let's look at letter H. Letter H is asking you to find the square root of a negative number. Okay, we talked about that in one of these other examples. This means I need 2 of a kind. I need 2 of the exact same number that multiplies to negative 25 in this case. Does a positive 5 times a positive 5 give me a negative 25? Well, that ain't going to work. What about a negative 5 times a negative 5? Does that work? Nope. Do I have 2 of the exact same number that will multiply to a negative 25? Correct. The answer is no, which means in this case, you do not have, there's no square root, no real square root, no real number. Good? Making sense? Okay. Now, use a calculator to approximate the square root of 22. Okay, you guys go for it. You've got to find the square root button on your calculator. Remember, when you don't see an index here, that automatically means square root. Okay, and there we go. Now, they said to check and make sure your approximation is reasonable. Okay, help me out. 4.690 is between which 2 whole numbers? If you said 4 and 5, you're right. Okay. If I take the 4 and square it, what do I get? Yes, 16. If I take the 5 and square it, what do I get? Yes, 25. If you take this 4.690 and square it, what do you get? Yeah, you get about 22. So, is the answer reasonable? Should the square root of 22 been somewhere between 4 and 5? Yes, it should have. And that's what they mean by reasonable. Good? Okay. Cubed root. The index tells me now I need 3 of a kind. I need 3 of the exact same number. You with me? Okay, Now notice, it says only if b to the third equals this original number. Let me give you an example. If I am looking for the cubed root of 8, I'm looking for 3 of a kind. What number multiplied by itself 3 times will give me 8? Hopefully you said 2. 2 times itself 3 times is 8, isn't it? Which means 2 to the third is equal to 8, isn't it? Let me erase something very quickly. 2 to the third equals 8, which is what they're trying to say here. So in this case, the cubed root of 8 would just be a 2. Cool? Okay. A is not restricted to being a non-negative number. You'll see. Let's look. So, cubed root of 27. Again, I'm looking for 3 of a kind. What 3 numbers multiplied by itself, what number multiplied by itself 3 times will give me a 27? And if you said 3, you're right. 3 times 3 times 3. That's what this means. 3 times 3 times 3 gives me that 27. Does that make sense? Okay. Now, I'm going to look at letter B over here. I'm looking at the cubed root of a negative 125. Now, first off, don't let the negative mess you up. I'm looking for 3 numbers multiplied, I'm looking for one number multiplied by itself 3 times to give me 125. Any guesses? If you said 5, that's a very good guess. Because 5 times 5 is? Yeah, 25 times 1 more 5 is? Yes, 125. But here's the deal. I need a negative 125. So let's see if this is feasible. Let's see if this is reasonable. Cool? So, if I take 3 positive 5s, clearly I get a positive 125. Let's see if I can have 3 negative 5s. Okay, so what's a negative 5 times a negative 5? Yes, a positive 25. And if I take that positive 25 multiplied by this last negative 5, what do you get? Yeah, I get a negative 125. So, is it possible to take the cubed root of a negative number? Correct. The answer is yes, which is why in this case, letter B has an answer of negative 5. Good? Okay. Let's take a look at letter C. Remember, this division sign, right? That fraction is a division sign, which means it's not superglued. So for letter C, I can take the cubed root of 1 and divide it by the cubed root of 125. Well, you know the cubed root of 1. Yeah. Sometimes the easy numbers are the ones that try to trick us. And we just figured out the cubed root of 125, didn't we? That explains that answer. Okay, let's look at letter D. What operation is between the negative 64 and the x to the power of 6? That's right, multiplication. So on letter D, I can look at this as the cubed root of negative 64 times the cubed root of x to the power of 6. With me? Okay, now, question. Can I take the cubed root of a negative number? Yes, because look at letter B. Letter B, I was able to take the cubed root of a negative number, and my answer was negative, wasn't it? Now, you need to find one number times itself 3 times. That is going to give you a 64. I'll wait. If you said 4, that's correct. Now, I want to look at those x's. How many x's are under here? That's right, 6 of them. Cubed root. Square root means we cut it into how many pieces? Yeah, the square root said we cut them into 2 pieces. pieces. The cubed root means how many pieces? Yes, 3 pieces, and they have to be the exact same number in each one, which means you will have 2 x's in each one, which is why it will be x to the second, which explains the answer for letter D. Does this make sense? Okay, loving it. Let's scoot on. Now, this is talking about an nth root. So this could be a 4th root, a 5th root, a 6th root, whatever root we're looking for. Okay, so don't get too bogged down in this n. N is just a number. It could mean any number. It could be a 4, it could be a 10, it could be a 31, it could be whatever number. Cool? All right. And again, the index. Remember that n is the index. If it's even, give me an example of an even number. Right. So a square root, or a 4th root, or a 6th root. Can I find any of these roots if the number underneath is negative? If you're like, I'm not sure. Remember, we tried finding this a couple of slides back, right? We tried finding this a couple of slides back, didn't we? Could we do either one of them? Correct. No. If the index is even, the root is not real. If it's odd, so now you got a cubed root, or you got a 5th root. So let me ask you something. We did an example. We took the cubed root of negative 8, right? We can take the cubed root, or we took the cubed root of negative 125. And could we do it? Yes, we could. There's my real answer. All right. Let's take a look at some examples. All right. Look at that first one. I'm looking for the 6th root. I need one number multiplied by itself 6 times to give me a 64. And you're like, how am I going to figure that out? You know, start small. If I take 1 times itself 6 times, is that going to do it? Yeah, no. What happens if I take 2 times itself 6 times? Is that going to do it? I'll wait. You figure it out. Yeah, you're right. It is the 2, which is why the answer is 2. Okay, look at that 5th root. How many of a kind do I need? Correct. I need 5 of a kind. And so I'm looking for 5 of the exact same number when multiplied together will give me a negative 1. Well, if you said 1, that's perfect. Are all those 1s positive? Good. Every single one of those 1s has to be a negative. And would the 5th root then of negative 1 be a negative 1? Yep, you got it. There it is. Okay, the 4th root of 256. You with me? Okay, you're like, how do I figure that out? Well, there are multiple ways of figuring it out. There really are. One way is to make yourself a little factor tree. And you could take the square root of that. Square root of that is 16. And these are both perfect squares, aren't they? Okay, so that tells me that 256 could be rewritten as 4 to the power of 4, which means the 4th root of 256 is, yep, 4. That's a lot of 4s floating around. 4 of a kind. Now, what about this negative 16? 4 numbers multiplied together to give me a 16. Yes, we did work this out before, I think. 2s, right? Now, I need a negative 16, though. If all the 2s are positive, it's going to be, correct, positive. If all the 2s are negative, don't answer too quickly. These 2 negatives give me a positive 4. These 2 negatives give me a positive 4. It looks like the answer is positive. Can I take the 4th root of a negative 16? Nope, I cannot. Good? Okay. Now, Let's take a look at this. It's interesting. You're like, why are these absolute values here? Can I take the even root, a square root, a fourth root, a sixth root? Can I take the square root of a negative number? We just tried this one. Could we do it? You're right, we could not. So we need to make sure the number underneath here stays positive at all times. Are you with me? Which is why if I am taking an even root of a variable, I need to make sure it stays positive, which is why the absolute values are a must. I need to make sure the variable will always stay positive, because if it goes negative, I'm in trouble. Can I take the odd root, cubed root, fifth root of a negative number? Yes, I can. That's not an issue. So I don't care if my variable is positive or negative, because I'm always allowed to take an odd root of positive or negative numbers. Cool? Okay. So let's take a look here. Letter A. I'm taking the fourth root, aren't I? Tell me, please, according to what they wrote, how many parentheses are under here? Yeah, 4 parentheses are under there. So that means the fourth root of these 4 parentheses would just be what? Yeah, it would be x plus 6, because I'm looking for 4 of a kind, and they gave me 4 of a kind. They gave me 4 of these x plus 6s in the parentheses. They gave me 4 of them. So that would be x plus 6. But a word of caution. Am I allowed to take the fourth root of a negative number? Correct. The answer is no. Remember, we tried taking the fourth root of a negative 16, and we couldn't do it. This variable makes it a wild card. I need to make sure that whatever number I plug in for that variable, it keeps x plus 6 positive. So to make certain it stays positive, I need to put the absolute values around here to make certain that regardless of what number x is, that whole thing stays positive, which is why the answer is written with the absolute values. Cool? Okay, so there was your letter A. Letter B. Okay, notice I'm taking the cubed root of this number, and this number is written 3 times, and I'm taking the cubed root. So what would I get? Yeah, I would just get a negative 3. No problem there. Okay? Plus, I don't have a variable on part B, so I don't even have to worry about anything there. Cubed root of something written 3 times as already is that number. In this case, negative 3. Okay, let's look at part C. Part C is asking me to take the fifth root of these parentheses, this parenthesis to the power 5, which means I have 5 of these parentheses, don't I? Which means the fifth root of these 5 parentheses would just be what? Yeah, it would just be the parenthesis itself. 7x minus 1. Help me out. Am I allowed to take the fifth root of any number I want? If you're like, well, I'm not sure. So let me ask you something. 5 is odd, right? 3 is odd, isn't it? We tried taking the third root of a negative 125, and we were able to do it. We said the answer was negative 5, wasn't it? I can take the cubed root of a negative number. I can even take the cubed root of a positive number. I don't care if my number is positive or negative, which means I don't really care what the x is in here. I don't care what the x is. If the x makes this whole number positive, great. If it makes this whole thing negative, great. I don't care, because I can take the fifth root of any number I want, which explains why there's no absolute values on part C. None. Part A, this index is even. Part B, this index is odd. When you have an even index, you need the absolute values. When you have an odd index, no absolute values needed. No absolute values needed. Last but not least on part D, remember, this is separated by multiplication. So I'm looking at the square root of 36 times the square root of x to the second. Well, I know this is a 6, and I know this is an x. But is that x allowed to be negative when I'm dealing with a square? Nope, which means I need those absolute values. I know the answer looks funny on part D, but because the index was a square, it was even, just like part A. It was even. Absolute values are needed, just like they were needed in part A. Cool? Okay. Now, when we talk about radical functions, all that means is there's a root in there. Square root, third root, fourth root, whatever root we're talking about. So let's just get used to plugging numbers in. Notice I have two functions. I have an f function and I have a g function. So please be careful what they're asking you to plug the number into. In part A, they're asking you to plug it into f, aren't they? Which means it would look like this, wouldn't it? You know what 7 plus 2 is as well as I do. That's right, 9. And this is a square root because you don't see the little index. And the square root of 9 is? Good. Part B. Part B is also looking for you to plug it into f. So it looks like this, doesn't it? Which means you get the square root of 2, don't you? Do you know what the square root of 2 is without a calculator? Yeah. So notice they didn't say anything about a decimal, so you leave it as the square root of 2 because they didn't say give them a decimal. With me? Okay. So let's look at letter C. Letter C says to use the G. So I'm going to use the G. And I'm going to plug the 9 in. And you know what 9 minus 1 is as well as I do. Yeah, that gives you the cubed root of 8, and we have figured out the cubed root of 8 already. Correct, it gives you a 2. Part D is also looking for you to plug it into G. And you know what 10 minus 1 is. And cubed root of 9. I don't think so. That's not a perfect cube. It's a perfect square, but it's not a perfect cube. So I'm going to leave it as just the cubed root of 9 because they did not ask me to give them a decimal. Good? All right. Now, let's graph. All right. So I am looking at plugging these numbers in to the square root function. Square root of x. Remember, f of x took the place of y, which means if I plug that in, I get the square root of x. And if we're graphing it, you might want to know what that looks like on the calculator, don't you? Okay, so help me out. What did you get for the square root of 6? Yeah, I got about 2.4. Okay? And let's plug the next one in. That means you're plugging in the square root of 4, or you're plugging in the 4, and you're taking the square root of 4, which is exactly 2. So no problem. The next one, you're taking the square root of 2 when you plug it in, which is approximately 1.4. Okay. You're plugging in the 1, which gives you 1. You're plugging in 0. Yeah, you can take the square root of 0. What is it? That's right, 0. Could I take the square root of a negative 1? Yeah, no. So it doesn't make any sense to plug a negative number in. And when I graph this, this is what my graph looks like. Good? Okay. I left some space here to do the next example, and you'll see why in a moment. So the first thing it asks me to do is identify the domain of this function. So let me go back. I am looking at the function square root of x plus 2. And remember, the domain means the input. And what variable am I inputting for? Yeah, in this case, I'm inputting for x. So here's the deal. Are you allowed to take the square root? Because remember, this index not being written automatically means there's a 2 there for square root. Are you allowed to take the square root of a negative number? Good. If you said no, that means that x plus 2, remember, addition and subtraction act like super glue, which means I have to look at x plus 2, not just x. Those things are glued together. The x and the 2 are glued together. So I have to make sure this x plus 2 remains what? Yeah, this needs to remain positive. Okay, you're like, how do I know when a number's positive? Don't tell me there's no negative sign there, because that's not it. Here's how I'm going to get you to remember a number is positive. Look at your number line. We were taught put the 0. Okay, all the numbers to the left of 0 are what? Yeah, these guys are negative. All the numbers to the right of 0 are? That's right, positive. Which means if I need x plus 2 to remain positive, I need x plus 2 to be greater than 0. Couldn't it be equal to 0? Isn't 0 considered positive? Yeah, it is. It's considered positive. So it could be not just greater than 0, it could also be equal to 0, because 0 is also considered a positive number. And again, those of you who need to put these little steps in because you're visual, please put them in. And when you finish solving, you end up with x is greater than or equal to negative 2. Let me remind you of something. So set notation, you just gave it to me. It's the set of x such that x greater than or equal to negative 2. But what happens if they want the answer in interval notation? Well, that means, sorry about that. Let me fix that a little bit. If they want interval notation, that means you need to graph x greater than or equal to negative 2. There's your negative 2. That's right, bracket going in the positive direction. Correct? Which means your interval notation starts at negative 2 with a bracket on it and goes all the way to infinity. So when I'm trying to plug in numbers to the function x plus 2, I can start at negative 2 and go all the way to infinity. So let's take a look at this. You know, they only gave me positive numbers. I'm going to plug in this negative 2 because we said, based on the domain, we said we could actually start at negative 2. So I'm going to start at negative 2. So the square root of negative 2 plus 2 equals what? Yeah, the square root of 0. What's the square root of 0? Yes, 0. Cool? You're allowed to plug in that negative 2. And then I'll go to the positive 2. And the square root of 2 plus 2, yeah, is equal to the square root of 4, which equals, yes, 2. And plug in the 4. Square root of 4 plus 2, yep, square root of 6. And I don't know about you, but I need my calculator. The square root of 6 is about 2.4, which I think we figured out before. Okay, let's keep going. Plug in that 7. Gives you the square root of 9. Yes, you know that. It's a 3. And the last number they ask us to plug in is this 14. square root of 16, which is 4, which explains the way the graph looks. Cool? See? You plugged in -2 and you got 0. Look where the graph is starting. It starts at -2 on the x's and it goes all the way into infinity. It starts at -2, goes all the way to infinity. Cool? Okay. Now, I want to get us a little bit of practice to find the domain of some other functions. Radical functions. So, what happens if you're trying to find the domain for 3 minus x? Again, since the index is not written, that means it's a square root. Cool? All right. So, you need to make sure that what's under here remains what? Yes, positive. And numbers are positive when they are what? That's right, greater than or equal to 0. So, let's do our work. We'll minus the 3 over, right? Which gives us negative x greater than or equal to -3. And I still need that x by itself, which means, that's right, divide both sides by -1. And you know as well as I do what happens when you divide an inequality by a negative number. Yep, that flips over, doesn't it? Which means your value for x is less than or equal to 3 in this case. So, you already gave me the answer for set notation. Set notation is the set of x such that x has to be less than or equal to 3. What happens if I wanted interval notation? Interval notation means you're going to have to, that's right, you're going to have to graph x less than or equal to 3. So, here's my number line, here's my 3 on the number line. And according to what you're telling me, I need x to be smaller than 3, which means these are my x's. And since it's equal to, I have a bracket, which means the interval notation will look like negative infinity all the way to 3 with that bracket on the 3. Cool? Okay, let me do one more example. What happens if I was looking for the cubed root? I wanted the domain of the cubed root of the same exact number, 3 minus x. So, with a cubed root, can I take the cubed root of any number I want? Hopefully you said yes, you can. Which means I can take the cubed root of positive numbers. I can take the cubed root of negative numbers. So the question is, do I have a restriction in this case? Do I need 3 minus x? Do I need it to be greater than 0? No, because I'm allowed to take the cube roots of positive and negatives, which means in this case, there is no restriction. So since there is no restriction, that means your domain is going to be anything you want it to be. Cool? Okay, you have fun with this stuff. Catch you on the flip side.